How's it going, everybody? In this video, we're going to go ahead and take a look at the next topic in our SD-WAN series, which is going to be NAT, Network Address Translation. So initially, we're going to take a look at some of the more common reasons why you would use NAT with the Vedge solution, or I should say the SD-WAN solution on the Vedge platform. And the reason why we're going to do that is because there's been a number of scenarios that I've worked in other overlay solutions like DMVPN and FlexVPN, where local internet connectivity is needed, where you don't want to send the traffic that doesn't need to go for corporate business over the tunnel to an HQ site to be able to reach the internet. Is that a bad solution? No, but it's a waste on bandwidth if your MPLS or your private WAN transport it's not there with the speed that it needs to have. So a lot of times you can get away with that with like internet service and then run a VPN over the top of the internet service. But we're going to take a look at deploying this in a way that where it's needed, we can actually deploy it. So in other words, we're going to roll this out on VH3 and VH4 via vManage and modifying the templates. I'm going to deploy this on VPN1 just to show you what it's like to configure it via the CLI, just so you can see the before and the after, and go from there. Now, we're doing local internet breakout. So the very first scenario that we're going to walk through is, let me go ahead and pull my pen tool out real quick, is we're going to set up internet connectivity here. We're going to enable NAT on the gig00 interface on Vedge1. We're going to enable NAT here, and that's going to allow us to send traffic, NATed traffic, out this interface. We're also going to create a default route to point to VPN0 that gig00 is a member of. So in other words, the default route will look like this: 0/0 with a outgoing interface of GE0/0, and it's going to be for NATed traffic. So any traffic that comes in from, say, iOS 5 or iOS 6 that is bound to an IP address or a destination IP that is not in our global routing table, that can be reached via the SD-WAN fabric, we're going to send it out to the internet like this. I do have a loopback over here on the internet router as 1.2.3.4, which we'll be using for reachability purposes. Now, the ASA has a default route on it as well, which is where we're going to be sending our internet traffic out of the gate. But because of the fact that I'm learning that default route, which is being advertised to switch 16, which is then pushing that down to Vedge2 and Vedge1 respectively, because the fact that it's going to be learned via OSPF means that I will be able to demonstrate this NAT configuration on Vedge1 without breaking my local internet connectivity, because I'm going to be using Vedge1 as my egress point, just to show you what it looks like in the CLI. Once we verify that it's working through Vedge1, we're actually going to remove the configuration and then default back to ASA1. The reason why we're going to do that is because I've advertised the OSPF external type 2 routes, which is what this is. This is going to be an OSPF external type 2 route, learned from the ASA, passes that to switch 16, and then switch 16 advertises that to Vedge1 and Vedge2. That default route is being sent over both T-locks this way, this way here, and this way here to these guys, and from here to here, and from here to here, as well as to here and to here, as well as to here and to here via MPLS on VH5, which means VH5 will eventually learn a default route towards either Vedge1 or Vedge2. So we'll be able to give the Vedge5 site internet connectivity. Once we have the configuration in place for Vedge1 and we remove it, just after we verify that it's working the way we need it to, I'm going to flip the config over, and we're going to take advantage of we're actually going to have one default route on Vedge3 and Vedge4 learn 4 different ways. The first 2 ways are going to be via Vedge1 via internet and MPLS colors, so through those T-locks, and then twice via Vedge2 via public internet and MPLS T-locks. So we'll learn the default route 4 different ways. I'm going to take the same configuration of Vedge1, but via templates over here on Vedge3 and a template here on Vedge4, which will allow me to test internet failover. Because what I'm going to do is on the outside interface, so GE0/0 and VPN0, I'm going to enable it to be a NATed interface, and then I'm going to create a default route on Vedge3 and Vedge4 that's going to do local internet breakout there as well. But if something happens with either gig 3 or gig 4 on the internet router, the upstream link goes down, which is a very real possibility. Local connectivity usually isn't a problem. It's usually something further up the internet stream that usually breaks. So in the event that the central office or the point of presence that your internet circuit terminates into goes down or has a problem, what will end up happening is after a short period of time, the BFD sessions will go down, and that will remove that static default route that we have pointing to VPN0 for NAT connectivity on Vedge3 and Vedge4, and actually allow the traffic for internet connectivity to route over the connections, the MPLS circuits, MPLS T-locks, back to Vedge1 or 2, depending on which one it prefers, and then send that traffic through HQ, through switch 16, and then eventually out of ASA1. So the configuration will look something like this. Let me go ahead and switch my color over real quick to yellow-green. So initially we're going to go like this, right? And we'll do something like that to the 1.2.3.4 address. But if something happens and these connections go down, right? So this circuit dies or this circuit dies, then we will no longer be able to get there this way or through this path right here. We'll have to take a different path, which is going to be riding over the MPLS T-lock through Vedge1 or 2 and then out to wherever we got to go. So this will be the new path that we'll be taking. We'll be riding over the MPLS T-lock in order to get to where we've got to go. That'll be high availability failover. So we'll shut down the interfaces on the internet router to simulate an upstream failure. It's going to take a couple of minutes for it to fail over, so it won't be an instant configuration. And eventually the traffic will fly over the MPLS T-lock back to the HQ site and terminate using the internet over at the HQ site. So that's basically what we're going to do in this video. Let's go ahead and start diving into the config to understand all the details that go into it. There's a lot to do, so let's dive into that config. So I'm going to go ahead and pull up Vedge1. And Vedge1, if we look at it here, we go ahead and let me admin in. Right, so if we look at a show IP route, we don't have anything going on in there right now. I did test this out, but I removed the config afterwards. You can see that I've got a default route in the routing table, right? So if I was to ping 1.2.3.4 via VPN1, I should be able to reach it pretty easily. Well, that's fun. Actually, yeah, that should be working. I'm not sure why that doesn't respond. Anyway, that would be the connectivity that we would want to be leveraging for internal usage, right? For whatever reason, it's just not responding. Not sure why. But at any rate, what's going to end up happening is on Vedge1, I'm going to go to global config and VPN0, and then interface GE 0/0. I'm going to type in the command NAT, which turns NAT on. So that's one thing to keep in mind here. if you're going to be, the way the internet or NAT works on an iOS router is very similar to this, where you have to go underneath the interface and basically say, you're going to be used for NAT. As long as you understand that, you're in good shape. You'll be able to process NATed traffic and all that good stuff. So the outside interface, GE0/0, or whatever interface you're plugging your internet connection into on VPN0 would need to have the NAT command enabled on it. I'm going to go ahead and I'm going to commit that command. And then I'm going to go ahead and get out of VPN0 and jump into VPN1. And the command I'm going to type in is IP route and just a default route. Because it's got to be, this is the destination you're trying to reach. So we're like, if you don't have a longer match route, send it out Vedge1 in order to get to where you got to go. So I'm going to go ahead and do that. And I'm going to type in VPN0. Simple as that. I'm going to go ahead and I'm going to commit that command as well. And then after a couple seconds, if we look at the show IP route, we should see a NAT interface added to the routing table, which we can. And this time here, it's learned, it's a connected route, right? So that means I should be able to go to, say, iOS 5 or 6, and if I do a ping to 1.2.3.4, after a couple seconds, we should see the ping go out, and if we do a telnet to 1.2.3.4, we log in and we do a show users, we can see that we are connected via 192.1.1.2, which tells me that our internet connectivity through Vedge1 is working. So we're doing local internet breakout here. And if I do same thing from router 6, ping 1.2.3.4, after a couple seconds the ping goes out and everybody's groovy. Now if we come over here to the vManage and we look at the network, I select Vedge1 and I look at this in real time, and I come in here and I look at NAT and I look at filters, and I don't want to filter anything. I should see an active session. So from 10.5.6.69 to 1.2.3.4, I have an active connection via TCP. And if I scoot this over just a little bit, you can see that my destination public port is 23. In other words, I'm using Telnet to connect. Now if I come back over here and I hit this up arrow and do a repeat of, say, 100, and I come back over here and I refresh, we should have an active ICMP ping right there. So we can see that that's working as expected. Protocol, or designated private source port is 1, and our destination port should be 1 as well. So it's a ping packet. All right, so that's local internet breakout on via the CLI. The configuration is identical on a Vedge that's associated via template. We're going to go ahead and go set that up and then go from there. So let me go ahead and remove this config on Vedge1. So go to global config and VPN1, no IP route 0.0.0.0/0 VPN0. Go ahead and commit that config. Boom, there we go. All right, now the next thing I'm going to do is I'm going to go do some verification testing. Let me go ahead and go to, say, iOS 13 real quick. Actually, let me show you Vedge3. So let me go ahead and do some config here. So let's do a show IP route. And we can see that we are learning 4 default routes. Technically, it's just one default route being learned in 4 different ways, right? So you can see that we have the T-locks that we're learning in from Vedge 1 and 2, because we've advertised OSPF over OMP, and that's where we're learning those routes from. Okay, so now what I get to go do is on iOS 13, if I come in here and I do a show IP route, I am learning a default route. So I'm going to go ahead and I'm going to ping 1.2.3.4, and I should be able to reach it pretty easily. There we go. I can ping it, and if I do a telnet to 1.2.3.4, I log in as Rob and Cisco. I do a show users. You can see that my public IP address is actually 192.1.102.2, or sorry, 101.2, pardon me. But here's the thing. That IP address is actually associated right here on ASA1, which means that I am flowing over the connection, the MPLS transport, or I should say I'm following a T-lock that points me back to the HQ site, and then the HQ site is getting me routed to the ASA. And the ASA knows how to reach back. So if I was to go to the ASA, which is right here, and then do a show con long, you'll see an active TCP session for telnet. Right there. There's my telnet session going through the firewall. Okay, all is well and all is great. Now that just proves that it's connecting, right? So if we go ahead and exit out here, and we'll do the same thing on 15. So I just want to prove to you that it does work this way. So we're going to ping 1.2.3.4. We do a telnet to 1.2.3.4, Rob and Cisco, show users, and we can see 192.1.101.2. Okay, so we verified that all of my claims are so far panning out. So now we're going to go configure vManage to allow VH3 and VH4 to be both internet breakout devices. So to configure that, we're going to pull up vManage, and I'm going to bring this over a little bit, and I'm going to, so we can see VH3 and 4, I'm going to go ahead and jump out of the way. I'm going to go to the Templates tab. I'm going to click on Feature, and the first thing that I have to do underneath the name of the template for single site, I'm going to come underneath here. I'm going to find the VPN0 template, but I actually need the VPN0 template for the gig00 interface. So the internet terminating interface in VPN0. I'm going to come over here. I'm going to go ahead and edit this. And it's got to be the interface. It can't be the VPN0 configuration itself. I'm going to click on NAT, and I'm simply going to come in here and click on on. Okay? I'm not going to mess with any of these options here. I'm just going to click on update. What that's going to do is it's going to push the command VPN0 interface GE0/0 to, and then NAT to those devices. Okay, so on the config diff, if we come down here a little bit, you'll see that underneath here we'll go underneath VPN0 GE0/0, and then we're going to just enable NAT there, configure devices, and push it out to both. Click on OK. Alright, so give that a couple of moments to do its thing. Alright, so the push is done and we're good to go. So I'm going to go back to the templates because we're not done yet. And click on templates. I'm going to go to feature template. And this time I need to grab the single site. Come down here to the VPN1 template. Let me scoot this over just a little bit more so we can see it all. So we need the single site VPN1 template, right? Because we have to create a default route inside of VPN1 to point out to VPN0 and leverage GE0/0. So I'm going to grab this template because we have to create just a default route in there. I'm going to go ahead and click on edit. And then under IPv4 route, I'm going to come down here and click on add route. And then 0.0.0/0. I'm going to select VPN, change this to global, and turn it on. Click on add, and then update. That's going to do this for both Vedge3 and Vedge4. I'm going to click on next. I'm going to do a quick config diff real quick. Give that a couple seconds to upload and update. Look at the config diff. And underneath VPN0, we have IP route, default route to VPN0. Okay? I'm going to configure devices, push it to both, click on OK, and then when that's done being pushed, I'll bring you guys back in. Okay, so now that the config has been pushed, let's go ahead and minimize this and go back to this guy. So we're going to go back to 13. I'm going to go ahead and I'm going to ping 1.2.3.4 again. Okay, the ping still works, which is good. I'm going to go telnet now. Rob and Cisco, and we're going to do a show users. You'll notice now that I'm not coming from 192.1.101.2 anymore. I'm coming from 192.1.3.2. And what IP address is that? Well, that happens to be the G0 interface of VH3, which means I'm pointing all traffic out towards the internet router, which is exactly what I'm trying to accomplish here, local internet breakout. So that's that one. So now if I go to VH or iOS 15, I do that ping. That one works as well. Let's go ahead and do a telnet, Rob and Cisco, show users. And now I've got 192.1.4.2, which happens to be the public IP address of VH4 on G00 and VPN0. So everything that I've trying to do is working the way that it's expected to. Now, if we look at the routing table of VH3, we do a show IP route just to make sure that everybody's on the same page. We're going to have this VPN1 interface here. We have a default route. Now, because it's default route, it's going to automatically take precedence because it's connected, right? We're pointing it out a local interface. Well, you'll notice on the OMP learned default routes, my next hop doesn't point out a local interface, it points to a TLOC IP. Anytime you have to jump more than one hop away, then you're technically not connected, right? So you have to jump over the over the IPsec tunnel to the remote TLOC device, which is in this case are Vedge1 and Vedge2, in order to reach the connectivity to do the internet routing. Now, what this does enable us, though, is this enables us to enable the failover. So I can actually go in and I can shut down the upstream connections on the internet router, and I can trigger the failover. The failover is slow. I'll warn you there. It does take a couple of minutes to trigger and to fail over, but once it does, our path will then be sent out over the OMP peerings via the MPLS TLOC, the MPLS transport, to Vedge1 or 2, and then out the ASA1 at the HQ site. Let's go ahead and take care of that. So I'm going to go to the internet router, go to global config, interface range G3 through 4, and I'm going to go ahead and shut down these connections. Now, pretty quickly it will detect the failure. So if we do a show IP route, it doesn't show it up here, but if we do a show BFD sessions, you'll quickly see that the connections are down. But it will take some time for them to get removed. In other words, this default route will stay in the routing table for a little while. This one right here will stay, and so will this NAT route. But you notice that because the TLOC went down, so did all of my public internet connections. I only have MPLS connections in the routing table at the moment, which means that once the local internet breakout failure switches over to use OMP only, the default route gets removed from the routing table, then I will no longer be using the local internet connection to go out to the internet. I'll be leveraging the OMP connection back to Vedge1 or 2 to go out via ASA1. So let's go ahead and actually take a look at, see how long that's going to take. So this is going to take a bit. I'm going to go ahead and pause until it's completely gone, and then we'll bring you guys back in. I'm going to try to time it for you. Alright, it took a lot less time than I was anticipating, which is awesome. So now we can see that the default route that was pointing out G00 is gone, and so is the NAT route. So if we go back over here to 13, and I come up here and I do the ping still works, right? But if I do the telnet, took a little longer this time, Rob and Cisco, and we do a show users, I don't know if you can tell, but it's actually slower. So we have this new connection going on, right? 192.1.101.2. Again, that's the ASA's IP address up here. If we exit out and we do a trace route to 1.2.3.4 numerically, we're going to flow out the ASA. Same thing on 15. If I come over here to 15, I do that ping test again. The ping works. The telnet works as well. Show users. It works as well. We exit out and we do a trace route to 1.2.3.4 numerically. We get out to the internet and everything's groovy, right? So that, ladies and gentlemen, is how you would enable local internet breakout via the CLI and via templates in order to allow local internet breakout and then to fail back to OMP connectivity to flow to the Vedge at the HQ and then hit the HQ's internet connection, or really a data center. It could be. It doesn't have to be anything. Now let's go take a look at Vedge5. Vedge5 is also going to have internet connectivity. I think I screwed that password up. I did. So if we look at show IP route, we're going to have a default route. Two of them, one through Vedge1 and one through Vedge2. And I will be able to go to 14. And in here, I'll do a show IP route. I have a default route in my routing table. So if I ping 1.2.3.4, give that a couple seconds. Boom. If I do a trace route to 1.2.3.4 numerically, boom, I get out to the internet all day long. So that, ladies and gentlemen, just verifies the claims that I've been making this entire time when it comes to doing the NAT configuration. So we're going to continue moving on with other NAT features and stuff like that in follow-on videos. But for right now, we are good to go with local internet breakout. Until next time, guys, thanks so much for stopping by, and I'll catch you guys in the next video.